ENCOR Section 21 Summary Challenge. Quality of service. Which three features are properties and one-way requirements for voice traffic? Voice traffic is bursty or smooth. It is smooth because it doesn't have any bursts, right? We have to transmit pretty much the same amount of data when we are talking on the phone or when we are staying silent on the phone as well, right? Because this silence is also encoded and it takes, I guess, similar or maybe even the same amount of bandwidth compared to when we are speaking. The latency should be below 400 milliseconds or below 150 milliseconds. Well, I think it's tolerable when it is 40 milliseconds, which is almost half a second of delay, but it may be noticeable, I guess. And I think for voice, the preferred value from the network perspective to provide better user experience is 150 milliseconds. Okay, and now for the bandwidth. The required bandwidth is roughly between 30 and 122 kilobits per second, and between 0.5 and 20 megabit per second. Okay, so definitely 20 megabit per second is really too much for voice, right? Because voice encoding works in a pretty efficient way, and I think up to 128 kilobit per second is sufficient for a voice stream. Which statement about QoS trust boundaries or domains is true? Okay, the trust boundary is always a router. No, it can be some other device as well. PCs, printers, and tablets are usually part of a trusted domain. No, that's the other way around, because these end devices, they are under control of their users, and users may configure these devices with some classifications arbitrary to them, right? And we do not want to trust these classifications, right? So actually trusted domain includes all the parts of the network, all the network devices which are under our own administrative control. We know how QoS is implemented in this part of the network, in this domain. The service provider and the enterprise network need to be one single trust domain, or else routing will not work. This is not a correct statement. It doesn't have to be. It's actually typically the trust boundary will fall on some device in between our network and the provider network. And the last option is the IP phone is a common trust boundary. Yes, it is a correct answer, because in a certain network setup, the IP phone also serves as a switch to which the user end device, like a desktop computer, is connected, right? And in this case, in such setup, this IP phone is under our administrative control from the perspective of the network administrator, but the end device is under user's control. So that's exactly why the trust boundary will fall on this IP phone. Which advanced classification tool can be used to classify data applications? Okay, so this is NBAR, which stands for Network-Based Application Recognition, right? And this is an advanced classification tool which can look deep into packets, into the data fields, perform DPI, deep packet inspection, and it can work in two different modes. One mode is passive, when it just looks into that, sees which traffic is there, which applications are working and using these packets, and then basically collect statistics and provide this information to the network administrator. In an active mode, it can actually use this information to classify traffic, mark packets, and then use this marking. This marking subsequently will be used as part of the QoS. How many bits constitute the DSCP field of the IP header? Okay, DSCP stands for Differentiated Services Code Point, and it is constituted by 6 bits of the IP header. Out of these 6 bits, 3 bits are taken by the IP precedence, and which is kind of a subset of these DSCP values. But overall, the amount of bits used by DSCP is 6. Which option is a layer 2 QoS marking? Okay, it is COS. I'm not sure if they pronounce it COS or COS, or probably COS, I guess, right? And COS is it is used on layer 2 to provide marking for Ethernet frames, and it contains 3 bits. Which QoS mechanism will drop traffic if a session uses more than the allotted bandwidth? So this is policing, right? So the action of policing, correct pronunciation is policing. So what policing will do, it will just drop excess traffic, right? In comparison with shaping, shaping will buffer excess data and will try to spread this excess data to a later time, right? To actually kind of deliver this data. And there is also a third method, which is remarking, which basically means that the excess traffic, excess packets out of the allotted bandwidth will be marked with a worse class and subsequently will have higher probability of being dropped or shaped, whatever. Okay. Which option is a congestion avoidance mechanism? Oh, I think I remember this one, and it is WRED, WRED. So it is kind of weighted random elimination, I guess, of weighted random elimination of some packets of some pieces of data, which are not yet, when the queue is not yet full, okay? So the whole idea of congestion avoidance is we have a queue, right? And this queue is not yet full, but we see that this queue is starting to being full, is close to getting full, and to avoid certain implications, we even start dropping frames before the queue is full, right? And there is a random here, which is important because what we want to do, we want to drop some packets more or less randomly, right? And we do this to avoid situations when we drop some traffic and then we would have this traffic being retransmitted by TCP, and this could potentially lead to waves of these retransmissions, which would not help anyone, right? So we want to introduce a little bit of randomness into this process. So we just pick up some random unlucky frames and just drop them. And W here stands for weighted, which means in this mechanism, it's this randomness is not purely random, like the less traffic class the packet has, it is more likely to be dropped. Right? It is not guaranteed that it will be dropped, but it is more likely to be dropped. Okay, and finally, match the question with the task that involves QoS policies. Okay, so these are our questions. Which traffic do we care about? What will be done with to this traffic? And where this policy be implemented? This should be a simple question. So the first thing is define classes of traffic. right? Which traffic do we care about? This is just a definition of classes. This is done with access lists, which kind of filter specific traffic, and then these access lists are applied to class map, right? To definitions of traffic classes as part of the class map. Then what will be done to this traffic? So this is policy, right? This is defined QoS policies for classes. Policy is an action, right? It could be dropped, which is called policing, right? Or it could be shaped. Different actions could be applied. And then finally, this has to be applied to a specific interface in a specific direction. So, and this is called a service policy, and this is how it is done. All right.